This video is going to discuss Newton's law of universal gravitation. The objective is that students will be able to recite the properties and factors affecting the force of gravity. So let's get started. You'll need a piece of paper for your notes and something to write with. Newton's law of universal gravitation describes the force between any two masses separated by any amount of distance. So no matter how far apart they are, or how much mass they have. This equation, this relationship, can predict and calculate and determine how much gravitational force will be between those two masses. So the equation is Fg equals gmm over r squared, or g times m1 times m2 divided by r squared, where Fg stands for the force of gravity, measured in newtons, like force always is. The m1 and m2 stand for the masses of the two objects, measured in kilograms. And r stands for the distance between the two masses as measured from the center of mass of each object, measured in meters. The g in the equation stands for the universal gravitational constant and has a value of 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared, which is a very, 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 very small number, like 0.0000000000667. This is the value of g, and it's the same everywhere, at all times, on every planet, in every solar system, in all galaxies, in all clusters of galaxies, forever and ever, all the place, all the time, forever and ever. And it must always be included when you use this equation. So every time you use the gmm over r squared, you have to remember to plug g in, or you won't get the right answer. I'm going to review Newton's third law of motion before we move any further. And Newton's third law of motion states that every time there's a force, there has to be an equal and opposite force. And this relates to Newton's law of gravitation as well. For instance, the force that Earth puts on you to pull you down to the surface is the same as the force that you put on the Earth to pull it up. And that sounds kind of goofy because you're like, I don't see the Earth moving. But since the Earth is so much more massive than people, it doesn't really appear to be moved or affected by it at all, even though it feels the same force that you do. Since the distance, which is r in the equation, is in the denominator at the bottom and is squared, the universal law of gravitation is an example of an inverse square law. This means that as that denominator, the distance, gets larger, and that the distance is bigger between the two masses, the force of gravity will decrease because you're dividing by a larger number. So time for a challenge question. If the distance between two masses is tripled, by what factor does the force of gravity between them change? Is it A, 3 times as much, B, 1/3 as much, C, 9 times as much, or D, 1/9 as much? If you said A or C, realize that those are incorrect. If the distance is greater, then the force is going to be smaller. So it's either got to be B or D. It's got to be a smaller amount than you started with. And if you said B, because you say triple is a factor of 3, so 1/3 as much, makes sense. Unfortunately, you'd be incorrect, because it's 1/9. That's because Newton's law of gravitation is an inverse square law. So that factor of 3 for the triple part would be squared. 3 squared is 9, so you have 1/9, which is 1/9 as much. That wraps it up for this PowerPoint presentation. Be sure to use your notes to complete the Edmodo quiz, and come prepared for next class.